In the last lecture, you have seen I've learned the Laplace transform of derivative, which is Laplace transform for first derivative is s ys minus y0. Laplace transform for second derivative will be equal to your s squared, for first derivative multiplied by s squared ys minus sy0 minus y prime 0. And now, we are going to learn the Laplace transform of integrals. If the Laplace transform for ft, if the Laplace transform for ft is equal to fs, then, and by definition is equal to the integral of exponent negative st ft dt from 0 to infinity, then the Laplace transform of integrals, here this is in the integral form instead of in previous lecture you have learned the derivative of division by t or multiplying by tm property, Cauchy property. Now this is in the form of integrals. Laplace transform of integral form is equal to fs over s. To prove this property, let's gt. Let the integral fu du from 0 to t equal to gt. The integral here, when integrate f with respect to u and substitute the limit from 0 to t, at last the result will be in terms of functions ft. Because gt, your integral is a function of t. The integral is in the function of t, let's say gt, and let's the derivative of gt or g prime t is ft and g0 equal to 0. Later on, we take the Laplace transform for g prime t equal to ft at both hand sides here. So you have a Laplace transform for g prime t equal to a Laplace transform for ft, and you have learned the Laplace transform for first derivative. If Laplace transform for y prime t is equal to sys minus y0. Now this is a Laplace transform for g prime t. Then will be s gs minus g0 equal to fs. The s, where the gs is actually Laplace transform for the gs is Laplace transform for gt. So you have s Laplace transform for gt minus g0 equal to fs. Remember, assume g0 equal to 0. This one is equal to 0. That's why left s Laplace transform for gt equal to fs. What you want to find is actually the Laplace transform for gt, hence is equal to fs over s. Remember just now gt is actually the integral. Gt is the integral of fu du from 0 to t. Hence, mean the gt is what we let in the initial step, which is the integral of fu du from 0 to t. Hence, the Laplace transform for the integral fu du from 0 to t is equal to fs over s. Example 1. Finds the Laplace transform for cos phi u minus u squared plus exponent negative 3u du from 0 to t. This is actually the fu. You have the form of Laplace transform of integral fu du from 0 to t. Using the Laplace transform of integral of fu du 0 to t, the result is fs over s. So fs over s. To get fs, identify your fu. In this case, is cos phi u minus u squared plus exponent negative 3u. Hence, taking Laplace transform for fu, you will get the fs. Laplace transform for cos phi u will be s over s squared plus 25. Laplace transform for u squared will be 2 over s to the power of 3. Laplace transform for exponent negative 3u is 1 over s plus 3. Hence, the Laplace transform of the integral fu du is equal to fs over s. So from the fs here, you divide by s. So the first term divided by s left 1 over s squared plus 25. This one divide by s, so 2 over s to the power of 4. The third term divide by s, so we have 1 over s bracket s plus 3. Call again Laplace transform for fu du from 0 to t. The result is fs over s. To get fs, identify fu. Then taking Laplace transform of fu, you get fs. So don't forget, after you get fs, divide it by s. Okay. The last example, evaluate the Laplace transform of the integral of exponent u minus 1 over u du from 0 to t. Okay, you notice here. You notice your fu is in the form of fu divided by u. Once you have to use the Laplace transform of first of all, you want to evaluate the Laplace transform of integral. So Laplace transform of fu du from 0 to t. The result is fs over s, where your fu is exponent u minus 1 over u. Okay. Identifying, fu is exponent u minus 1 over u. To get fs, okay, to get fs here, identify your fu. Okay. After you get fu, you need to transform take the Laplace transform to get fs. However, to do the Laplace transform for your fu is in the form of, fu divide by u. Okay, divide by u. Recall back, okay, the Laplace transform for ft over t will be equal to the integral of fs from s to positive infinity, provided the limit of ft over t when t approaches 0 exists. Hence, to evaluate your fs, you notice that your fu is in the form of fu over u. We need to solve your fs by using division by t property. This is the division by t property. Before you can use the division by t property, you have to make sure that the limit, in this case the example is limit of your fu over u when u approaches 0 exists. Okay, so in this case, this is a limit of eu exponent u minus 1 over u when u approaches 0. So you plug in u by 0, exponent 0 you have 1, so 1 minus 1 you have 0. In numerator, when the denominator you plug in u equal to 0, you have 0. So this is in the intermediate form of the division by t property that we have learned in the previous lecture. Hence, to get the limit which is in the intermediate form, either 0 over 0, infinity over infinity, or you have infinity minus infinity, you can use the L'Hopital rule, where you just differentiate the numerator and denominator separately. Don't use the quotient rule. Okay, then you differentiate exponent u, you have exponent u. Differentiate negative 1, which is 0. Differentiate u, which is 1. Now you plug in u by 0. So exponent 0, you have 1. 1 divide 1, you get 1. So the limit exists. Okay, once the limit exists, in this limit exists, then you can find the Laplace transform for EU minus 1 over U use division by t property, which is equal to the integral of fs ds from s to infinity. Okay, the fs here you don't mix up with our initial fs. Okay, so now we in division by t property. To get the fs here, this identify the ft, okay, in the numerator. Okay. So you want to find the fs, okay, this one. You want to find the Laplace transform for EU minus 1 over U, which is in the form of Laplace transform for ft over t. That's why you use division by t property. Division by t property, which is equal to the integral of fs ds from s to infinity. S to infinity. Okay, so to get the ft, identify the numerator, which is exponent u minus 1. Once the fs is taking Laplace transform for exponent u, you have 1 over s minus 1. Laplace transform for 1 is 1 over s. Hence, Laplace transform for exponent u minus 1 over u is equal to the integral of your, okay, the fs that you obtain here, ds from s to infinity. Integrate 1 over s minus 1, you have ln s minus 1. Integrate 1 over s, okay, so you have ln s. Okay, so you combine these two ln, minus, it become ln s minus 1 divided by s. Okay, if you plug in infinity, in the infinity here, you may have a form of ln infinity over infinity. To make sure, okay, what we get, we divide, okay, by highest polynomial term, which is s power 1. So s over s minus 1 over s, denominator s over s. Simplify it, we have 1 minus 1 over s divided by 1. Now we plug in infinity into s. So you have 1 minus 1 over infinity over 1 minus with substitution of the lower limit here, where you get actually this one is in you can simplify, or initially is come from the term s minus 1. You plug in here s ln s minus 1 over s. Okay. Later on, simplify 1 over infinity is equal to 0. And then you get this is ln 1, which is equal to 0. So you have negative bracket, okay, ln s minus 1 minus ln s. Okay, we expand inside the bracket, so you have minus, so positive ln s minus ln s minus 1. So the result is ln s over s plus 1. Okay, this is the result for Laplace transform of, this result is actually Laplace transform for exponent u minus 1 over u. Laplace transform for exponent u minus 1 over u, you get ln s over s minus 1 using division by t property. Okay, and then now what we want is the Laplace transform of integral exponent u minus 1 over u du from 0 to t, where you use the Laplace transform of integral. The result is your fs over s, where the fs, you get fs ln s over s minus 1 and then divide by s. So lastly, the result is here, divide by s. In this question is a bit confused because in order to get, the Laplace transform for integral, Laplace transform for integral fu du from 0 to t is equal to fs over s. to get the fs, means you need to find the Laplace transform for exponent u minus 1 over u, where we solve it using division by t property. If we solve it by division by t property, this is ln s over s minus 1. Hence, the Laplace transform for integral of 0 to t exponent u minus 1 over u is the fs that you obtain divided by s. Okay, and to solve, okay, the Laplace transform for exponent u minus 1 over u, remember this is in the form of fu over u. Fu over u. If you call back your division by t, you have ft over t integrate s to infinity fs ds. Okay, hence this one you need to integrate to solve your Laplace transform for this one, to solve your Laplace transform for the form of fu over u. Before you can fu over u, okay, fu over u, which is equal to fs ds from s to infinity. Before that, you have to make sure that the limit fu over u exists. Okay, after exists, the ft is actually from the numerator, your numerator, and then you take the Laplace transform for your numerator, you get the fs, and then integrate from s to infinity. In here, you have proof that the limit exists, and then okay, to find the Laplace transform for exponent u minus 1 over u, okay, identifies the numerator is actually your ft. So the fs, okay, you transform it, you get the fs, and then you integrate your fs ds from s to infinity. This is what you have done just now. So you get this one. Then now you want this one, the integral of exponent u minus 1 over u du. This is using Laplace transform of integral is the fs over s. Okay, where this is the fs. And you divide it by s. Okay, with this, thank you for your attention and watching the video.